things here, it's you is going to do that. um the other thing is that I hope, let me check my, this can work here. So I believe that your workbench is working. Believe that your workbench is working and you are able to do some coding. It is able to connect. No connections. It's telling me no connections established. Um, can maybe example. Or let's do this. I think because of time, I'll be able to handle these next session. Let me explain the, or I want you to do this just now. Let me open the example. Bench. I think my workbench is crashing here and there. Let me see if I can uninstall it and then redo it. Bench. Install it. Yeah. I think let it just go fast, but still we can be able to use the normal uh, access to our databases, and then you can be able to do the SQL queries here. If the workbench is still loading because of time, So you either use the workbench or you can be able to start with that. Number one is that given this question that the Catholic University of Eastern Africa database. So we are saying that Queer University wants to design and implement a relational database systems to support its academic and administrative operations. The system should capture information about students, lecturers, courses, departments, exams, fees, and libraries. So these are the requirements for the students' records. There must be a student ID, full name, gender, date of birth, email, phone, and enrolled in one of the departments. Then a student can register for many courses, and each course can have many students. Then this lecturers table. Each lecturer has a lecturer ID, full name, and email and phone, and they belong to one department. So a lecturer may teach multiple courses in a semester, including those ones which are outside their departments. Each department has a department ID, department name, and office location. The departments oversee the students, lecturers, and courses. We also have the courses. Each course has a course code, course title, and credit hours, and it belongs to one department. Courses are taught by lecturers and registered by students. Exams. Each exam record excludes exam ID, includes exam ID, course code, student ID, and exam date, and the marks allocated. Then we have the exams results, which are linked to both the student and the course. With the fees table, each student has fee record with the fee ID, student ID, amount payable, and amount paid and balance. For the library maintains book ID, book title, author, ISBN, year of published. The students borrow books with borrow records containing borrow ID, student ID, book ID, and borrow date, and the return date. So, what is the task that you're supposed to do? Design a relational model design. Create tables for all the above entities using SQL. Create tables statements. Clearly define the primary keys, candidate keys, and foreign keys. Apply the entity integrity, which must be unique and not null. Apply referential integrity, that is for foreign keys must reference existing primary keys in parent tables. B, you have to consider the following properties of the relations. Ensure each relation has one, unique tuple or not duplicates, atomic values, no multiple valued attributes, and three, proper attribute naming convention. So for the practical query here is that insert at least 5 sample records for each table. 2, write SQL queries to demonstrate. 1, list all the students in the computer science department. Find all courses taught by a particular lecturer. Retrieve students who scored above 70 marks in database systems course. Calculate the total fees balance for each student. Show books borrowed by student named Mary Achieng. D is that views, because you also I want to look at the views. So create a view that shows students' exam performance with student name, course title, and marks. Create a view for the finance department that only displays a student name, amount payable, amount paid, and the balance. Create a view for the library that shows student name, book title, and return date. Uh, on the reflection, I want you to explain how your design demonstrates number one, terminologies of relational models, two, how tables represents data, and three, properties of relations, and four, candidate keys, primary keys, and foreign keys, five, entity integrity and referential integrity, and six is the purpose and advantages of views. So these are key things that I want you to be able to articulate and explain in that situation. I think I can be able to send this question to you people so that you start working on that. Where is that? Have I opened this? Okay. Ta, ta, ta. Yes, so I want to use this. Uh, so there is a question. There is a question, and we're supposed to do that practically here. Solve that. So first you install the workbench, and here's the code that you're supposed to work on. Although I want first of all to explain the concepts before I look at that. So in the last lecture, we looked at the introduction to database. Uh, Today, I want us to look at database environment. So you look at the purpose of tree-level database architecture, contexts. You also look at the distinction between DDL and DML, classification of data models, and all these other things. So I just want to go very fast. That number one is that all users should be able to access them data, views, and so on. So let's look at DBA. So a DBA should be able to change database storage and so on, internal structures and so on. So let's look at this structure here. As we look at this structure, I want us also to look at this situation here. Sorry, this one here. What do you get from this? What do you understand from this? Given this kind of a diagram for you, what do you notice? So, based on the question that you've had, for you to develop the relational model design, you will require to first of all design the database based on their tables that are respective tables that are needed. Then from those tables, you need to identify which ones are primary keys, secondary keys, candidate keys, and all that. Therefore, it's very important that you have to identify such. So to answer that question, you have the department, which is like the mother. Therefore, the department is said to have department ID, which is your primary key, department name, office location, either Zadwa or H or whatever. So you have lecturers. Every lecturer has a lecturer ID, which is their primary key because it uniquely identifies them. Nobody shares the same ID, but you might find two or three lecturers sharing the same name, but they cannot share the ID. Emails. Every lecturer has their own email. They are always unique, but these emails cannot be the primary keys. So they will serve as the candidate keys. Why? Because it can be used to identify the lecturer course and the course code within that. So you have the lecturer courses, you have the courses, you have the student course, which is broken down from the courses. So courses can be many, but then an individual student has their own courses. Just like now you are doing CMT 302, but there is somebody who joined with you who is not doing CMT 302, is doing something else. So that means that the student course are also distinct. Therefore, those ones can be identified by the student ID and the course codes. So the course code can be both a primary key and a foreign key, depending with where is it reflecting. So we're going to look at all these terminologies so that you can be able to understand what's the primary key, foreign key, where is it used, candidate key, and all other forms of keys that are available. So for the book, you have the book ID, the book title, author, ISBN, and the year published. You have the borrow, which is borrowed ID, student ID, book ID, borrowed date, and return date. So all these are things that you needed to understand from that. So to start that, I want you to write some lines of codes within your SQL or your MySQL area, which should be able to work and operate very perfectly with you. So for you to create a table for the department, then you have to use the term create a table, then you give the name of that department or the name of that table. So we are starting with department. We will do for course, for lecturer, student, book, exam fees, borrow, student course, and lecturer courses. So in all this, we need to understand certain structures. That like that diagram breaks for you how those elements are being displayed. So that gives us to talk about the database environment first. So you have external level of the database, you have the conceptual level, you have the internal level, and then you have the physical data organization. So within the three level architecture, external, conceptual, and internal, then what makes up the external level? External level is made up by the users, you who is interacting with the database. But you are not doing injections to the database in terms of modifications. But what you are doing is you are just inserting values and making request or retrieval of data. And then you can as well as update from your end as the viewpoint. But you cannot be able to create that database from scratch. The one who can create that database is the person who is the administrator. Therefore, for him is accessing in the internal level or conceptual level. So we want to look at all these levels so that you can be able to have a good breakthrough. So external level is made up of users, and users interact with the view of the database. They describe that part of the database that is relevant to a particular user, and the view mostly we can refer to it as a form being designed that you can easily interact with it, that has got the fields summarized and other things that you can be able to interact with the database directly from your end. Then the next thing is the conceptual level. This means that the community view of the database, where it describes what data is stored in the database and the relationships among this data. That's what the conceptual levels will handle. Then we have the internal level, which is the physical representation of your database on the computer. It describes how the data is stored on the database. So in case you wanted to get about how those fees, the lecturer courses, the student courses, the departments, if you want to see where is this primary key, where is this, and so on, then you will need to look at that. Now, what's the difference between these levels? External views, conceptual, and internal. Now, for external, what people are just seeing are the forms that they are interacting with. For instance, you are feeling something like you are registering the course. What do you see from your end? You only have to pick the date and the time that has been allocated there, and then pick the unit that appears there. And then you'll be able also to see the name of the lecturer. Then you register. So you are just interacting with a graphical user interface. That's a view level. Sometimes we call them a form because it's easily, you are just interacting with it. Save, click, register, and move on. Now in the conceptual level, you are now looking at the table structure, but you are not seeing the code. So you can decide that now, from the conceptual level, you had the staff number, full name, first name, last name, date of birth, salary, and branch. Now these two can be splitted. You can have the staff number, full name, age, and salary. Then you can have last name and the branch. Maybe you are within another branch. So what can we do? These are separate tables that we can easily merge them because they are storing the details of the same person. So once we merge them so that we remove the duplicates, then we can have a conceptual level. So when you are doing normalization, breaking down this table into a simplified form, then you are building a conceptual level. Then when you now write the codes to define the indexes, point out to the next staff records, help people to access these, and so on, build a complete structure and the entire table now at the background, then you are now doing the internal level operation. So what's the database languages that we know? We talked about data definition language, which allows the database administrator or a user to describe and name entities, attributes, and relationships that are required for that application. So we've just looked at the ERD diagram that we have. You've seen the structure of the UMLs. Every table with what is supposed to be implemented. So those are entities and attributes, because entities you are talking about department or the people that you are representing. You are representing fees, you are representing exams, you are representing books in the library, you are representing lecturers. So these are entities. Every entity has got their characteristics or features that needs to be captured. Those describes the attributes. Now every lecturer has got a lecturer ID, lecturer name, has got the lecturer age or lecturer salary and whatever.
So all these are attributes that are helping to explain or to describe the entity who is a lecturer. If it is about books, there is ISBN, the book title, the book ID, the book, the author, and so on. So, plus any associated integrity and security constraints, they are always also being defined within the DDL level. Now, the second one is the DML, which provides you with the basic manipulation operations on the data held in the database. The other thing that it provides is that it provides you with the procedural approach whereby the users can tell the system exactly how to manipulate this data. Whether you are updating, whether you are modifying, whether you are dropping, whether you are altering the table, you need to be able to be notified on that. Then we have non-procedural. So we have two types here, procedural and non-procedural. In non-procedural data manipulation language, users are allowed to state what data is needed rather than how it is to be retrieved. So that is what is very key. Then we have the fourth generation language, which is also used in these database languages. So in fourth generation languages level, here we talk about integrated collections of concepts for describing data, relationship between data, and the constraints of the data in an organization. So you will look at the fourth generation, because the fourth generation are now the current types of databases that we are interacting with. But so those are the key languages first. We've known about DDL, we've known about DML, procedural DML, non-procedural DML, and then the fourth generation language. We have what is called the data model. So what is a data model? It's simply an integrated collection of concepts that describe the data, the relationship between those data, and the relationship that can be established, that is the constraints or the restrictions that exist between those organizational structure. Like you can see the student course and the lecturer's course. The table should be able to allow the lecturer can teach this, yet the student is the one who has chosen to teach to do the other one. So it can fit anywhere, but it should not restrict that all the courses that I am teaching must be taken by the student. No, the student should be able to take as per their level, semester, or academic journey state. So, what is data model comprises of? The data model is comprised of the structural part, manipulative part, and the possibility of the set integrity rules. These are very, very key fundamentals. So, when dealing with the model, a data model, the key purpose for it to exist is to represent data in an understanding way, so that you understand this data. What is the structure? How should it be represented? How can I be able to modify it? And where can I be able to insert it and store it? Categories of these data models. Number one is object based, record based, and physical based models. So what is the object based data models? This entails the entity relationships, primary key, foreign keys, candidate keys. All these ones needs to be brought together to be able to tell what's the entity relationship between the other table and the other table, and what are the key elements that are used to identify the relationship between these two tables. We have semantic, functional, and objective or object oriented. So those are the object based data models. Then we have the record-based data models, which are comprised of the relational data model, network data model, and hierarchical. Then we have the physical data models. Let's look at relational data model. You have the branches and then you have the staff. Where, as an organization, has got branches. You have GABA branch, Uzima as a constant college, even Tangaza used to be one. Then you have the staff. Now, a staff can either be in both branches or in one branch. It can either be in Langata campus, main campus, or GABA. The student can be either in the faculty of law or it can be in the faculty of education or faculty of computer science. So a staff can belong to one branch or many branches, but a branch cannot be in different staff areas. It is a staff who is movable. Therefore, you can have the branch number, street, city, postcode, and within the staff, you can have the staff number, first name, last name, position, sex, date of birth, salary, and branch number. Now, we have some common fields in this area. In these two tables, you have got the branch and then you have got the branch number in the branch and the branch number in the staff table. So, branch number is a primary key in branch table, but it is a foreign key in the staff table. Okay? So, in order to identify which branch does this staff belong to, you will have to call the unique numbers that identify different branches inside the staff table. So you have here network models are like this. So relational, we have different tables that are linked to each other. That means that one table or each table must have a relationship with each other, either one to one, one to many, or many to many. That's a relationship or relational data model. Then you have the network model where you can group your models into a hierarchical level, either in terms of the access levels or as per the city or the postal codes region. So you can break them into hierarchy based on the levels. Like you have, for example, the DHIS2, District Health Information Systems, or the Education Server Database, because you have the national level, then you have the county level, then you have the sub-county level, then you have the ward level or the division level first, then the ward level, and then now until the village level. So even education, categories of schools, you have those ones which are division level, sub-location level, you go to the sub-county level, county level, like that until you get into the highest level, which is the national level. So that is network, hierarchical in nature. But then when it comes now to network, you can have one branch being related to other different staff members. So one staff can have a network to different branches. So that is you have a network that is created. Mostly we talk about many to many relationship gap. So hierarchical, I finished explaining that. You can look at the conceptual models. So what is conceptual modeling? Since we started with the first level, which was external, what is conceptual modeling? When talking about conceptual modeling, you're talking about a conceptual schema, which is the core of the system supporting all the user views. So, a conceptual model should be completed and it should be accurately representing an organization's data requirement. Also, a conceptual model now the process, because now modeling is now the process of developing this model or metadata of the information that has the ability to use what is independent of any other in details that are supposed to be inside that data. So in short terms, we say that the process of developing a model of information to be able to use that is or which is independent of the implementation details. So when you're doing that, then you are now creating a model. So the results of these conceptual models is always having a functional database management system. Because in all this, if you are trying to link up all these to do whatever, to build these schemas, create the relationship between them, create the linkage between each of the tables or existing departments that you are building the tables for, you are just building the database that is well connected. So what are the functions of DBMSs, database management soft systems? So within this, we have data storage, retrieval and updates can be done by that. The user accessibility catalog can be done by that. Transaction support, we have concurrent control services, have recovery services, we have authorization services, support for data communication, integrity services, services to promote data independency, and the utility services. All these are very powerful functions of a database management system. So components of database management system. What are made up of the database management systems? We talked about the programmers, the users, the database administrators. Then we have the DBMS area, which is made up of database management language, the data manipulation language, query, DDLs, program object code, database managers, dictionary managers. We have the access files methods. Now from now the database and the system catalog point, the file managements and all this. So all these are components within that structure. So within the database, we have a multi-user architecture approach. We had first of all the ANSI 3 level, which we have finished. Now, what is the multi-user level? We have the teleprocessing, the file server, and the client server. So when you look at what is teleprocessing in a multi-user database management systems architecture, this one refers to the traditional architecture that was commonly used, where the single mainframe with a number of terminals was attached to each other during the building of these databases. So trend is now towards the downsizing of this. Then you can now have that kind of a structure that now you can have one element connected to one center, one centralized point there. So that is teleprocessing, and all of them connected with a network cable to ensure that data can be shared and can be moved from one area to another. Then we have the file server, which is connected to several workstations across the network. Database resides on a file server. This one is more commonly used in hosting areas. So a DBMS and application can run each workstation in that area. What are the advantages of this? If you are using a file server system, there are significantly network traffic. There is a copy of DBMS on each workstation. There's concurrency, recovery, and integrity control more complex in that area. So file server means that you can have several workstations linked to the same network, and this network is now linked to the same file or main server area. And what is contained in the server, all the servers are connected to different databases or a single database that contains all the data that is needed. Traditional two-tier client server. So this one, mostly you have the client, like for example, one client who can manage the interfaces, the user interfaces, and runs the application. Also, we have one server or two servers who holds the database and DBMSs, and all their categories and functionalities are well splitted. We have advantages of using this traditional two-tier client server. One is a wider access to existing databases. We have increased performance, possible reductions in hardware costs, and reductions in communication costs. And also we have increased consistencies. So that is what you can be able to have in all these areas. Client side also presents two problems. These problems needs to be resolved. Number one, you find that you have significant client side administration overhead, whereby one user or one administrator is overwhelmed by so much tasks because he cannot be able also to assign, maybe due to the breakage of rights and roles access level. Then we have a fat client requiring the considerable resources and the client's computers to run effectively. So in 1995, that's when we had the three layers proposed, each potentially were running different platforms. So the three-tier client server now came to provide some advantages. One of them was to have a thin client who requires less expensive hardwares. The application maintenance was centralized to one point. They were easier to modify and replace. Separating business logic from database functions were made easier, and also mapping was quietly natural for web environment. So that's how it used to be: first tier, second tier, and third tier. That uh, makes the end of that section first. So we've looked at all this to have a better, clear understanding to that. Now, having looked at all those, we can now look at what is called, we can look at what is called relational models. Let's look at relational models now. And when looking at the relational models, we are going to understand these types of keys so that you can be able to have a clear understanding of that. I think I can first of all also check something here about the keys. I wanted to have a simplified concept on that to make it, yeah, this one, so that I can easily explain this here. So we have a primary key, foreign key, composite key, candidate key, alternate key, surrogate key, and natural key. So what are they? Primary key are unique identifiers for each record in a table. They cannot contain null values, meaning that they must be unique. Examples, you talk about the user ID. Then a foreign key is a field or a collection of fields in one table that refers to the primary key in another table. For example, in an orders table, you can have user ID, which is from the users tables. So when it appears in the orders table, then it becomes a foreign key. So we shall be able to look at all that in a detailed state. So one thing is, what is a relational model? First is a relation is a table with columns and rows. So when asked to define what is a relation, just know that it's a table with columns and rows. They only applies to logical structure of a database, not just the physical structure. What is an attribute? Is a named column of a relation. A column within a table is what is called an attribute. What is a domain? Is a set of allowable values for one or more attributes. Is a set of allowable values for one or more attributes. This content that is allowed to be within this one attributes area, and it could be able to be accepted. That's a domain. So what are relational, what is a tuple? A tuple is a row of a relation. So one row is a tuple. What is a degree? A degree is a number of attributes in a relation. A degree is a number of attributes in a relation. Then we have, what is cardinality? Cardinality is the number of rows in a relation or in a table. Cardinality is the number of rows in a table. Then we have relational database is now a collection of normalized relations with distinct table names. A relational database is a collection of normalized relations or normalized tables with a distinct table names. So for instance, these instances of a branch and a staff relation. So there is a relationship between a branch and the staff. So the branch, we talked about the branch number being a primary key in a table branch, but it appears as a column in a staff table, but not its own primary key of a staff table. Then it becomes a foreign key. What is a degree? So you've seen that, the number of rows within a table. Cardinality, yeah, there. So I've demonstrated there. Examples of attributes. We have at branch number. You can talk about street, postal codes, and so on, date of birth, salaries, and so on. Alternative terminologies, you talk about a relation being a table, being a file, a tuple being a row or being a record, an attribute being a column or a field, and so on. So what is the database relations? We're talking about relation schema. What is a relation schema? Is a named table that is defined by a set of attributes and the domain name pairs. That is what a schema is. So a relational database schema. These are a set of relation schemas with distinct names. And then you have properties of a relation, talking about the name that distinctively from all other relations or names in a relationship table or schema is what we use to define as that. And then we have each cell of a relation contains exactly one atomic or a single value. We also have another property or characteristics of a relation is that each attribute has a distinct name. Also, values of an attribute are all from the same domain, meaning that they uniquely or entirely describe the same entity. Each tuple is distinct. They are not duplicates. The order of attributes has no significance. Even if you take the order to be where, to the primary key to be at what level, as long as that is what you have said, this is the primary key, it will work. So what are relational keys? Super key. A super key is an attribute or a set of attributes that uniquely identifies a tuple within a relation, while a candidate key is a super key that no proper subset is a super key within the relation. So when you have a table that doesn't have a super key, then that field that was representing a super key now becomes a candidate key. So meaning that each tuple has a relationship, and the value of each relationship is uniquely identified within that row. So no proper subsets are involved. A primary key is a selected unique within a relation or a table. An alternative keys is a candidate that are not selected to be primary key. A foreign key is an attribute set within one relation that matches the candidate's key. So integrities here, you talk about being not null and being null. Being null means it represents a value for an attribute that is currently unknown or not applicable for a row. It deals with incomplete and exceptional data, and it also represents the absence of a value. So null means you can leave it blank, but not null means you cannot leave it blank. You must fill it. Null means optional, not null means it's a must. Entity integrity, we have them there. Referential integrity, can be able to look at that. Views. So views, we have base relation, which are named relation corresponding to entity conceptuals. A view is a dynamic result of one or more relationship or relational operations operating on a base relation. So that is a view. So contents of a view are defined by queries or also just a form. You can be able to use it to dynamically make modifications to that. So what are the purposes of a view? Number one, they provide powerful, flexible security mechanisms. They permit users to access data in a customized way. They simplify complex operations on base relationship. So this one about updating views, you can be able just to look at them. I think that is very important there for your case. I think that one is also well articulated. You can be able to look at the relationship models, because these ones are just easy. You can be able. So what are ERD? Concepts of ERD or entity relations table or modeling. So first of all, you need to know about what are entities, relationship types, attributes, and so on. So what is an entity type? An entity type is a group of objects with the same properties identified by the enterprise as having an independent existence. So you can have a group of objects, which is staff, branches, and so on, university campuses, and so on. They are objects that have their own properties, and they are identified using their own organizational or attribute structures independently. That's why fees cannot be the same as exams, so they are different. So entity occurrence, we say uniquely identification of object as an entity type. So what are examples of entity types? Physical existence, you are talk about staff, proper, customer, and so on. Conceptual existence are viewing, sell, work, experience, and inspection. So what are ER diagrams? For instance, here we have an entity name which is staff and branch. So a staff and a branch are all entity names. So what are relationship types? A set of meaningful association or networking or coordination or linkage among entity types is a relationship type. So a relationship occurrences, when do they occur? They uniquely identify associations, which includes one occurrence from one each participating entity. So for example, you have a branch has a staff. Every branch has got a staff, and several staff can belong to different branches. That's a relationship. So a degree of a relationship is the number of participating entities in a relationship. So how many number of entities are inside a relationship? If there are two or three, then those are the relationship types. Those are the degree of relationships. Then you have relationship degrees. Either they are two, three, or ternary, or four, or quaternary in nature. So binary relationship, which we call them as private owners. For example, here we have a private owner and a property for rent. So there exists a property for rent which belongs to a private owner. But one property owner can have several properties for rent. Is it true? So you look at this arrow where it is pointing. The arrow will point to where more independence is involved and where majority of them depend on the primary section. So private owner can have many private properties for rent, but many properties for rent can belong to one property owner. So tertiary relationship is where a staff registers a client at a branch. So when you go to as a staff, maybe for example as a lecturer, maybe I'm serving a student at Quer Langata campus, and again I serve the student at Gaba campus. Then I become a ternary relationship called registers. So you can be able to register various clans on various branches in various branches, or various branches can register various staff within that scope. So those are the concepts that are needed for that to come. So I said here private owner owns property for rent. So you can either own a property for rent, or you can have several rentals, property rentals owned by one private owner. So you're dealing with what is called binary relationship. Then we have the register. A register can be a ternary relationship between a staff and a branch. So what does it mean? A staff can register a client at any branch or every branch. So that is ternary. Then we have quarterly, which is that now arrangements. A buyer has financial institutions. So a buyer can send a bid to a financial institutions, and this can be two or many. So that means that a solicitor arranges a bid on behalf of the buyer, supported by the financial institution. So if the financial institution does not support what the buyer, a bid that the buyer wanted to get, then it can be quashed off. So a solicitor is one guy who arranges bids on behalf of the buyer, who is being supported by what? Financial institutions. Then we have relationship types. Recursive relationship. This is where the same entity type participates more than once in a different role. So you can have one primary key, which is both a foreign key, candidate key, alternative key, and so on. So meaning that that entity has operated in very many areas. Then you have a relationship may be given role names to indicate the purpose that each participated to perform. Recursive relationship, sometimes we call them supervisors with role names. For example, here, a staff can be a supervisor who supervises staff or staffee or supervisee. So, like a student can be supervised by by one lecturer during attachments and so on. So that can happen like that. Entity association. So a manager manages branch offices. So a manager is head, and as he manages the branch offices, he is managing the staff and is the one who is assigning all those roles. So a branch office has member of staff, and this member staff belongs to different branches. So that can be this is a very good example of such issues. What are attributes? Are properties of an entity or a relationship type. We have an attribute domain, which is a set of allowable values for one or more attributes. So we have simple attributes, which are composed of a single component with an independent existence. We have composite attributes, which are composed of multiple components, each with an independent existence. We have a single valued attribute. This is where you have a whole single value for each occurrences of an entity type. We have a multiple valued attributes where you hold multiple values for each occurrence of an entity. So, which is very, very, very important. Derived attributes, we say that they represent a value that is derivable from a value of a related attribute or a set of attributes, not just necessarily the same entity type that is involved. So let's talk about keys. You have candidate key, which is a minimal set of attributes that uniquely identifies each occurrences of an entity. We have a primary key, which selectively and uniquely identifies each occurrence of an entity type. We have composite, which is a candidate key that consists of two or more attributes. That is composite. So that is a small diagram to show those structures and explanations. We have a strong entity type, which is not existed or dependent on the same on some other entities. We have weak entity type, which is existent of the dependent on the same other entity type. Strong entity type called client, and weak entity type, which is called preference. I think a newspaper advertises properties for rent. Relationship called advertises with attributes. So when you have a newspaper, it can do an advertisement about several properties. So it will tell several property number, and then now from here, what are the primary keys? Property for rent, you have a property number, which is a uniquely identified value. That's a primary key. You come to newspapers, or have what's called a newspaper name, newspaper ID, and so on. So when was the advert being made about this document, maybe through a newspaper or whatever, can now serve as an entity in between all these other two tables. So structural constraints, we have the minimal types, the main types of constraints on relationship. So what are these? So when we are being asked what is multiplicity, it's it's simply the type of the number of possible occurrences of an entity type that may relate to a single occurrence of an associated entity type through a particular relationship. That is what we call as multiplicity. So it normally is used to represent policies, especially like in business rules and so on. So the most common degree for relationship is the binary, and binary relationships are generally into three main. One to one are represented using one colon one, and you can use one to many where you can say one and then asterisk, or you can do asterisk asterisk. So you can have one manager managing several, like here. So you can draw that, which we have already explained. Each property for rent is advertised in zero or more newspapers. So you can say zero asterisk. So that is one to many. Each newspaper advertises one or more properties for rent. So you can put there one, then many, and so on. So I think I want just to end here. Cardinality, participation, you can be able to read that. Cardinality describes maximum number of possible relationship occurrences. Participation determines whether all or only some entities occurred, particularly in the relationship. And therefore, I want to end my discussion there, so that now you can be able to have. I want you to code this within your SQL instead of spending much of the time here to work on the same. So let me share with you the file. Uh, so I think that one I'll handle that. Wanted to share with you some question here. This is yes, this one, so that you can be able to file location. So I want you to code this at your own free time. Code that to show that as the solution to that question. So because I'm very exhausted, I want to end my session there so that I can also even get some water to take. So I just want to read your attendance. You'll attempt that work. Let's go to this. Please be attentive. I really want to take a rest. Collins Kipkemboy,
Present.
Obiambo Mike, Jeff. Jeff is absent. Gladys Wawira, Mwaniki, Jesse Baraka, Jesse, Peter Lewis, Mburu, John Kivanda, John.
Excuse, sir.
Yes.
Odhiambo Mike is present. I had a problem with my microphone.
Please unmute faster. Very tired. Jesse, are you there? Gladys, Peter. So John, Oure, Lawrence Chumba,
Present.
Kiera Nyambura,
Present.
Norman,
Present.
David, Kirubi, Michael Mwangada, Renson, Jemima,
Yes, present.
Len, Otich,
Present.
Ivan Kiprop, Simiu, Lisa Waruguru,
Present. Present.
Mary Katie Nyutu, Mary, Isaac Morris,
Present.
Andrian Baker,
Present. Present.
Donald Kiprotich,
Present.
Joe Chomba,
Present.
Macharia Maderi,
Present.
Dennis Deng,
Present.
Denim Kili,
Present.
Nicole Nyarwai, Ndegwa,
Present. Present.
Sami Mwigai, Tuo, Sami Mwigai, Trevor Some, Nyang'au, Werason Mulu, Kioko, Victor Paul, Mwangi, Eric,
Present.
Kate Kipiegon,
Present.
Anita Alice,
Present.
Cecilia Adol,
Present.
Frida Mwikali, Karege Dibora, Stella Mukwe, Kura Stewart Muridi,
Present.
Joseph Mungai,
Present.
Derek Wekulo, Vincent Kimuru, then Brian Mawira.
Present.
I have not called who? Deborah who? What is the name of Deborah? The other name. Deborah, where is your name? that. Uh, Kazek. Which number? Send your admission number. Tired. Kazege here. Who else here? I think Philip. I already read your name. That is Rachel and Dave. Philip Kamundi. Philip, where is your name here? Philip, I don't see your name. I think I finished with this. Anybody I've left aside? Philip, I don't see Philip your name. Paul Karanja, Rachel Ondiek, and Dr. Please, let me save this. Let's meet next week once I'm done with the funeral. I have a burial I have to travel today. I have a flight to catch in the next few minutes. Attempt that work. So this is 27th class attendance. 7th May. Thank you. Have a blessed time. Have a blessed time. Allow me to take a rest.